What's going on, chat? How's it going? All right. Howdy, howdy. Let's get right into it today. Let's see if my network cooperates. It's putting up a little bit of a fight, but we're gonna try. It's actually wild because now my encoder isn't the problem; it's my network, which unsurprising. This is not new, so I'm okay with this. How's everyone doing today? Alcius, Nightshade, welcome in. Yeah, we're gonna try and get this stream schedule a little more regular, so hopefully you can stop by more often. All right, let's see. What do we need to clean up today? Certified code janitor day. For some reason, I'm getting like a weird thing here where if I do like try router dot. All right, let's see. Router. Why is it not working? It's just like const router equals router. So let's try this. If we do zig var router equals zig. That's not what it is at all, is it? For just fermion router. Okay. Why is that not working? But if I do this, does it work? Let's see. Imports. We take yeah, that should be fine. Let's see. Yeah, that's very strange. Let's see. Also, I think they came out with a new version of that TOML file, and I really do not want to have to update for that. Let's see. Let's see. Okay. Let's see. So we have the Zig fermion router, which is here. So like it builds, but it's so weird. Like it's not oh, I know it. It might be a oh, we're gonna do this and I'm gonna break something, but we'll give it a shot. Is it gonna break? Let's find out. After a message No, just kidding. No, that would be wild though. There's a strong likelihood this thing is going to break and just not work at all. Yeah, there's a strong chance it might just completely get borked right now. Zig build. You guys saw that, right? You get a Zig build that like on a after you updated a flake and something didn't break. That's crazy. Yeah, I need to fix this, but there we go. Yep, there we go. I thought it might be that. That happens too frequently. All right, cool. So we have the. All right. Well, that's fixed. Nice. We probably should gate that code so that we probably should lock that version, actually. All right. That looks good. The main looks quite good. Route requests. All right, I'm digging these tunes, but man, that is a little loud for me today. At least in my end. Probably not on your end, but okay. Let's see. Let's see. What do we need to split out here? I think we're actually getting to a really decent spot on this and like actually getting it to work, which will be super nice. We don't use our file anymore. Yeah. All right, let's look at root. Let's just kind of walk through this top to bottom and see. I want to look at the router. Method, post, get, create. Oh, there was something I was going to look at of maybe doing comp time based string stuff. Let me see if I can find that real fast. I saw a pretty cool implementation of a radix tree, or like of a comp time router that I was kind of intrigued by. Let's take a look. Apple Pie is an HTTP server written in Zig. Yeah. But they have this thing here. This. Where it like this is a comp time route building thing. So let's take a look. Apple Pie .router. I think this is pretty cool. Let's see. Can I insert into a comp time string map? If I had to take a guess, probably not. But I guess you wouldn't really need to, right? Because like, yeah, I guess you wouldn't need it because you can say pub const router, or let's just do a quick test. Comp time router struct. I would really like to use comp time in this discussion because I think that it's kind of the thing that makes Zig cool. Routes. Let's see. Standard dot. So hold on. Let's see. So in this one, oh, I hate this stuff where you return a comp time type. It sounds like a great idea, and then you sit down and do it, and you're slowly pulling your hair out over comp time stuff. Like it's cool, but yeah, it gets kind of hairy. A big thing that we actually really do need to add is we do need to add a pointer, like a context. That's something I really do want to implement because we don't have that, and that's not great. Because that's basically what we could use to tie these things together. Like that's how we could. I think we could use context on middleware. I think that would be kind of where it plays out really well. So we create a comp time router with a comp time string map. What's going on with my network today? It is usually not this bad. So what if we do yes. So that's how we would do that, I guess. So let me just kind of walk you through what I'm thinking here, chat. So with the comp time string map, it takes a comp time value, which is your type. So in this case, it'd be a handler, and the key, which is going to be a constant value. Now, there's a couple things about routers that why I think this could be a really good choice for using comp time. Mainly that in most cases, you'll know what your routes are ahead of time. Your code gen is going to happen like it's all going to be static, right? You're not at runtime changing your routes. Not to say that you couldn't, but in this case, probably not, especially in a serverless context, right? You want that to be static. Hey, how's it going? Welcome in. Yeah, so my thought is like if we use a comp time string map, then we can compile that map and we get out, we get that all out at once, which would be very interesting. Whether or not it's going to work, that's a different question. And I'm kind of having trouble wrapping my head around it right now. And admittedly, I don't know enough Why do they return a type, though? Oh, I guess it's because it's generic, then. The handler function that will be called, which is handler here. Where is that? Does that even run? Let's see. Oh, wait, hold on. Yep, a handler is this function. Something that it takes for parameters, returns any error or void. Expecting more WASM shenanigans tonight. Yes, as you should. As you should. Admittedly, I think tonight it's probably going to be Zig shenanigans more than WASM shenanigans, but we are working in WASM still. But we're gonna play. I think we're gonna attempt some comp time handling of these things. Let's see. Path handler method. What does ours look like? An HTTP handler, which is a handler, a array list of methods. Which I could see being a problem of like comp time stuff. Route, struct path handler method. Handler method. Yeah, I'm really fascinated by this, if this works. So all right, so they're saying var trees is this, and we pass it in a array of routes. I guess that's how you have to do it, right? Because you basically have to. The only way that you can keep it like generic without having to do some weird passing between and like keeping all of this comp time, you'd have to use a type, because the type gets determined at compile time. You can't set it now. What's the wrap function do? Let's see. Wrap will automatically convert router captures from a list of key value. Let's open this up. Will automatically convert router captures from a list of key value pairs, an array of entries, or a slice of entries to one of the following. Nothing if the handler function has only 3 arguments. A single string if the handler function looks like this. A struct where each field is an array, and each field name is one of the parameters in the path. Multiple parameters. Oh, that's fascinating. So what this is doing is this is a handler that's capturing the post and message URL parameters. Const post, standard format parse int. Yep, and then there's that. Oh, interesting. All right, so I think that... So these are all GET requests, and then we're saying builder.get post message messages. Let's see, messages. That's so interesting. So, chat, why is this important, right? Like, why? Who cares? So, what this is doing is it's generating the. First of all, it's generating the map, like the rate extreme map that's being used for routing under the hood at compile time. Interesting, so that's not a runtime constant. The other cool thing here is that this mapping is very dynamic because it's using something called. So if we trace it, right, we have this builder.get. So if we look at the builder.get function, which is down here, .get takes a basic route, get a path, and a basic route is this return a route that takes a method, a path, and a handler, and it wraps the handler with a context. And then what you do is this gets wrapped here. So we say, okay, cool, let's wrap the handler. So we wrap it. And then the wrap function, what it's doing is if you're familiar with like runtime reflection in Go, it's similar. It's not exactly the same because it's happening at compile time. What we do instead is we wrap the function and it says, hey, take the handler and the context, which the handler is any function basically. So it says, okay, cool, this is a function. Get the info. Take the args of the function. The first one is the contents. The second one is a response. The third one is a request. And if there is a fourth parameter, there's no parameters. So there's no parameters here. Then we say, if there is a fourth parameter, then we say if it's a string, then we'll just pass that. If it's a struct, then the struct basically gets a function where you can call the field, the fields that are there. So how does that look, right? How does that manifest? So you get these captures, which are going to capture the post and the message parameters here. So we parse out the post and the message. Yeah. Gets wrapped. For params and param. Inline 4. So basically it's matching the parameters of the struct to the internal parts. So like it's saying like, hey, you have a struct. So you're iterating through the struct fields, and we're comparing that to the parameters of the. Where is that coming from? Oh, from that are set in the tree. So we're checking that, and if it matches, then we return it, and if there's an extra field or something, and then we just say we error out. And then what it does is it returns a handler where you have the captures, and then it returns the wrapped value back to you, which is this. So returns the function back. It's interesting, but it's very convoluted. Because then, I mean, it makes the developer experience great, right? Because you say, cool, I want to capture the route parameters that look like this. Awesome. Which is cool. That's very cool. But that sounds a little overkill for what I'm trying to do. Like really overkill from what I'm trying to do. Yeah, I don't know. So I don't think right now we want to do that, but I could see a use case where we could, right? So a comp time string map, like I said. I'm pretty sure I've used one of these before. I just don't remember when. Yeah, because I remember you have to like pass in all of your parameters. Oh, I guess we're already doing that, right? A comp time list of routes. Interesting. LCSS. Okay, so okay, what in the pray tell is going on here? Just got done looking through our new guys' implementation of some ECRs for a project. How's the functioning going? How's the arc functioning? Smooth so far? Any funkiness with the dual GPUs? No. I gamed on it yesterday. Completely fine. It worked well. Admittedly, right now, all of the issues I'm having with encoding are actually due to my network and not the GPU. The GPU is great. It sips power, uses like 10 watts at like when it's encoding. It doesn't break a sweat. So much better than AMD's encoder. Yeah, no, it's awesome. It's incredible. Yeah, if the next Intel card is great, like if it actually has decent gaming performance, 100% I'll buy an Intel card. I will beta test that card for sure. I'm so sick of Nvidia's crap with gaming cards. No, it's ridiculous. I shouldn't have to pay that much for a graphics card. And AMD, I mean AMD's good. I like my AMD card a lot, but I just think there's some cool stuff in Intel. Heard the Intel cards are very good overall, just not for the DX versions. For the older DX versions. Yeah. Yeah. They've come a long way. Like the Intel cards were bad. They were very DirectX. Yep. The DirectX versions. Yep. No, they were bad. They were very bad. And then what's cool though is that some of the newer the Intel cards used basically a driver they ported part of DirectX to Vulkan, the translation layer. On outside of their onboard graphics. Yeah. So they ported part of the DirectX to Vulkan translation layer that like the Steam Deck uses, and they ported that to support some of their older DirectX titles. So now the DirectX performance is actually really decent, and they do a ton of development on those cards. They're very cool. They're very cool pieces of technology. Yes, they're not like AI inference workhorses like Nvidia cards, but they're very cool, and their price point is actually great. So that's the cool thing. So the Intel A310, which is the one I'm using right now, graphics performance, but I don't care, right? Because I already have one. I just need an encoder because AMD CPUs don't have encoders, and the GPU encoder on the 6800 XT, which is what I'm rocking right now, does not. It doesn't have an encoder. Oh, okay. It has an encoder. It is awful. Do not use it. It's so bad. It's gotten a lot better, but still awful. So the A310, which is the one I got, single slot, 50 watt TDP maximum under load card, powered off the PCI Express bus. You don't care about AI, just care about encoding graphics rendering. Yeah. I don't. Okay, I wouldn't say that like it's great. I don't know if I would buy one and be like, yes, this is going to be a graphics rendering workhorse, but it's great at encoding. Because like you could honestly probably do, like a mix where you do like AMD for your rendering and then encode it with Intel. I don't see why you couldn't. But yeah, that was my thing. I was like, yeah, I just need a card to just encode these streams, man. And then also it has an AV1 encoder, which is great. We're not using it right now because we're on Twitch, obviously. But when Twitch allows for non-NVIDIA AV1 encoding, I'm there. I'm there. Admittedly, that's what I wanted to do. I wanted to use this card to do AV1 encoding and then stream with AMD to. So we'll use AMD to, or my CPU basically to do the Twitch stream, and then I use AV1 to. So Nightshade, check out the Sparkle A310 Eco. That's the one you should take a look at. Actually, any of the Sparkle cards, I think most of them are bus powered. I don't think they're externally powered, which is nice. I've admittedly, and the nice part was for me, I was like, all right, great. Well, after I'm done with this, I'll just throw it in my server, and I'll use it for media encoding. Like I'll use it on Jellyfin, because as long as you have a new enough kernel, you can just get great out of the box drivers for it. Like just awesome like drivers. All right. All right, cool. All right, cool. Alcius, you asked what we were doing, and I will show you. Are you still around? I can break this down for you. It's two parts, but I just want to make sure you're around. I'm still getting used to like recognizing if I'm running ads or not. Yeah, I'll wait another couple minutes, and then we'll hop right into it. But I will demonstrate it here. I need to come up with a better like example of this that's like more exciting. But Alcius, if you're there, and for anyone new watching who hasn't watched the stream before, hey, my name is Ninjatron. Ethan Holtz on Twitter. Come say hi. But what we are building today is the Zig Fermion router. So if you're not familiar, Fermion is a WASM. Yep, there was an ad, then you heard your name. Yeah, all right. Yep, I thought so. I'm still getting used to running the whole ads thing. I'm going to be honest. I don't understand Twitch sometimes. But what I was saying, I was just about to explain what we're doing here, right? Because it's been a while. So this is kind of fun. So this is the Zig Fermion router, which uses the Fermion platform, which is this, which basically is we don't want the Kubernetes one. We just want like Spin. So Fermion Spin is basically a way that you can write serverless WASI apps, and that's what it does. So you basically write some WASI code, you compile it, you put it on their platform, boom, you got a serverless WASI like framework, and that's what it does, and it's great. It's honestly incredible, super nice. So what it's pretty cool. And I've been using it for a while to kind of just play around with like WASM and hosting WASM and what's it all about. So WASI, so one thing that it doesn't have is explicit support for Zig, but all WASI compatible languages work. It just doesn't have an SDK for all their platform features. So what does this thing do? Great. So the Zig Fermion router is a platform that you can build a simple API almost, if you've ever used Go, Gorilla Mux style router for WASM. Hello. So yeah, so what it does is you get to use like a Go style interface to create API routes that run serverlessly in WASM. So this is all happening. So every instantiation of this router is technically a serverless function. And we use it, and what it does a couple things. Number one, you get all the comfortable parts of using Zig. So you get to use all your WASM stuff. That's great. You have to write pretty canonical Zig as well. We use the WAGI interface under the hood, which we can talk about in a second. And then the other thing is it also generates all of the deployment files you need to deploy. So it uses this spin.toml file, which is like the spin manifest to deploy on the platform. And this file gets generated at build time based on what you use here. Now, I have a couple things I might want to try down the road. But for right now, it just generates it uses these basic templates and generates all that at build time, and then puts it out there, and then boom, there you go. You get a fully functioning server. And so let me show you. If we go to Zig out, you see we get a binary. So cat bin. Oop, nope, that's not what I wanted. ls-alh bin. We get a 1.3 megabyte router that's fully packaged, so that's all of your pieces. And that's your WASM run. That's what you're going to run on WASM. Thank you, WL Clipboard. Very cool. So that's what it's going to do there. And then it also generates your spin.toml. So all you got to do is you do spin up, which is the spin command. You hit spin up. Your router is up. You're now running it serverlessly. We can curl that endpoint. Boom, there you go. And also we have support for running it actually on the Fermyon cloud platform, which is basically an instance of spin, but it runs on in the cloud, which is awesome. It's great. It's a lot of fun. But yeah, that's the meat of it. That's all it does. And we've added some cool things. So you get scoped logging as well, all done at compile time. So you just specify like if you need debug or like what mode you're going to use, and it does a compile time. Thanks, Neutrino. I appreciate it. But yeah, that's all it does. So you get all this stuff like, hey, this is a log, whatever, and you can do it. And then a couple other things. So Alcius, you'll remember our protein databank project back in the day. I kind of hacked on that a little bit more, and it can now actually translate from protein databank files to FASTA files, which is awesome. It's pretty cool. Granted, it's not very accurate. I didn't know that when I wrote it, and now I'm paying through that. But one thing that you can do is you can write client-side WASM, use your serverless function to serve client-side WASM, and then run it in the background. So this whole application here, which does the parsing, and we can kind of demonstrate that actually. Let's see if it works. So you get the file. Let me not dox myself real fast. Let's see. Okay, cool. I got one right. Load it up. Okay, so we can take a PDB. We click the PDB. We click load. So what's interesting here is that whole load happened on the client. So all of that work was client-side WASM. Yeah. So this used to be server-side WASM plus HTMX. The next goal is full stack Zig-based WASM. That's what we're doing. That's the goal. And don't even get me started on my experimental service worker-based router here in a second. I have plans to do that, but we'll get there. There's a couple Zig issues with WASM that I need to hack and /or make nicer before I do that. But yeah, so this is all done in the client. It's all done in the client, but all of the backend is being served by the WASM in the backend, and it's actually using the Fermion router. So if we take a look, we can look at source main. It's not pretty, but basically we just embed the index, the HTML file. You don't have to do this. We can actually handle static files as well, but we embed the HTML file into the body. We just embed it into the WASM binary. Which if you ever use like embed in Go, it's kind of similar. So we do that. We add some headers here for cores. We set all that. Boom, there you go. So all you get, index, you set your index, your front end file. Boom. You create static routes, which is where you're loading your PDB, this is loading your client-side WASM. Then you also have the route that if you want to, you can still swap it out and use backend WASM if you want as well. And the big benefit, let's see. Almost this code also is pretty much almost exactly the same under the hood. So you can write kind of one piece of code and it works on both client and server. That's the dream. That's the dream, people. So what we're here for, we're building full stack Zig. Not because anyone asked, because they definitely didn't. But we're going to do it. And isomorphic Zig. Ooh. I like that. That's a good one. Isomorphic Zig. Yeah. So that's the TLDR. That's what we've been working on. You get if you've ever worked with Leptos, it's pretty heavy. I ideally at one point want to get up to there. I'm not a big front end person, so my front end part of this project has been kind of lacking. But the back end is exactly what I like to build with. It looks pretty similar to Gorilla Mux. It looks very similar to that, and that's what I built. That's why I wanted to build something that looked like this. So just kind of show you that. So if we look here, it's very similar. Very, very similar. The HTTP handle is different. Like we don't do that. We just say, hey, when you're done, just route everything. Call it a day. And then also we can't directly set the host because of spin. But we get this like methods kind of thing here where we can specify it using either the standard HTTP methods or we can use post. And then headers, you can set. We can't do header matching yet. That's one we do have to add. Is the code for the PDB thing public? Great question. So yes, we have two different versions of it though. So the front end, back end stuff, not yet. It will be at some point. I'm not ready to release that mess yet. Because I showed you the pretty part of that file, but there's some work that needs to be done on my projects for that. But the actual PDB parser itself is. So Sonic PDB is the library that it's using under the hood. So I wrote this library to parse PDB files. So I'll drop that in here. We have another one called Knuckles RS. Let's see. Can I do this without, doxing my private repos? Let's see. Knuckles RS is the other one. This one's a little more experimental, but it does something similar. So yeah, and there's Knuckles RS. So yeah, it's the same thing. So those are the parsers, and the advantage is that we can use, because we're using a WASM context, you can actually kind of mix the components. I do some full stack stuff, and I want to see how far I can do. I can go with pure Zig. Yeah, I need to clean up some stuff first. But if you're interested in Zig WASM, we can definitely take a look at that starting next week. Is my goal, because I'm pretty much going to put a pause on Zig Fermion router. It's at a point where I'm happy with how much it can do. Hey, thanks for the follow. I appreciate it. But yeah, so I'm happy with where Zig Fermion router is at. I think it's in a good spot. Next week, so I'm doing a podcast with Fermion next week. We're gonna do that on Tuesday. After that, my goal is to go back to doing client side WASM. There's actually a big issue with client side WASM with Zig. So let me show you what it is. So when you write client side WASM, you have to, let's see, I think it's, oh, because I'm not tracking it yet. So when you write client side WASM, you have to export all of the functions you want to use, kind of like you're doing a dynamic library. Yeah. No. We'll get there. We'll get there. Yeah. No. My goal is next week we're gonna start working on it. We're gonna do it. So here's the problem though. So when we have the export function, this is supposed to like show up in your like a dynamic library, right? Or a static library where it like puts out function, names that are exported. That's what it's supposed to do. It's just not. So what you have to do is you have to actually do some stuff here. Oh no. Oh shoot. How do I stop them? No. Give me 1 second, chat. Well, that's a first. Yeah. Weird indeed. Let's see. Oh well. We'll ban him. We'll get him out of here. Well, we got most of them. We'll call it a day. Sorry about that, chat. Yep, there we go. Cool. Yeah. Yeah. But yeah, well, so basically what I need to do is we need to get the export symbol names into some sort of, like, this needs to be put into the build time. This needs to be added. And what I'm going to do is I think the best way to do it is I'm going to have to write a way to parse the syntax tree before you build, which we can do in Zig. Like the Zig build system is able to handle that. That's what we need to do. We're going to add the ability to do that. I've seen other people where they like put basically like pre-processor macros. I don't want to do that. We can just parse the ASC directly. Zig exposes all of that. Let's just use it and run with it. So yeah, that's what we're gonna do. But yeah, that's kind of the big thing, because I think once you have that, writing client-side Zig is a lot easier. Admittedly, though, now that I think about it, we only really need to export a router if we're doing it on the client and we're using a service worker, because we could just say, hey, route this function in and return back a string, right? Which is arguably kind of what a router is doing anyways, right? It's also adding some headers and stuff like that. But I wonder if there's a way that we could just have it just return back a string, kind of similar to what the WASM implementation does. I think it should be the same. But yeah. All right, so cool. So let's make sure. So here's the last thing we're trying to do. I just want to clean all this up, get this looking good, and I think I'm pretty much there with how everything looks. I just want to make sure that there's no code in here that looks kind of weird, as in like we're calling an allocator, like rather than using the internal allocator, etc. Okay, that looks good. Yep, I think the last one is response. Do we use the response allocator? Oh, I guess we have it as an option. Yeah, so you can do something like this, like the response allocator. If you wanted to allocate memory, you can go here and say like, hey, response. If I can spell, that would be great. Response.response allocator. It returns a copy of your allocator, and you can use it for whatever you want. Cool. All right. Well, I think this is a good enough spot here. So we're gonna do something fun. And by fun, I mean potentially breaking. No. There we go. What we're going to do is we're going to zpdb. We're going to not Nix, Zig, fetch, save. We're going to get the Zig Fermion router and see if we can still build this Zig build. Hopefully we should. And we cannot. Nice. Yes. Okay. So that's a big one. So one of the things we changed in our last video was we basically we removed the need to like pass the allocator in here. So you just pass it one time. And we're also going to update Zig. Nix Flake update. Now we might now that I've updated both, the likelihood that something's going to break high. Generally I can do one, but doing both, absolutely not. Oh, yeah. There's also a weird bug, Zig format, where like the Zig format cache doesn't get populated sometimes, and it freezes up the LSP. And admittedly, I need to file a PR for that. So basically what happens is if your Zig format version doesn't match, like if you update it, it'll freak out at you. And now you see, we got nice highlighting again. Wow. Okay. So let's do a Zig build. So now we don't need to do this. And now we never allocate or change that. Chat, did we just do it? Did we do an update and nothing broke? It's a first for me. It's a first. Let's take a look. Promising. Oh my gosh! I feel great. See, this is a moment, Nightshade, where me bragging about the fact that I don't think you're a mod on my channel was probably not the way to go. Add. Let's see. Let's see if it works. Might need the mod view. We'll see. How do I even get to the mod view? I don't even know. Yeah, no, that doesn't work. Let's see. Can I open it up? Yeah, no. Ah, okay. Oh, I had to turn on. Oh, I see. Yeah, we'll do that after this one. But I needed to turn on shield mode. Good to know. Now I know. Oh. There we go. Yeah, I will do that after this stream. Because it's going to clear chat. I'd like people to be able to see what's going on. Cool. So yeah, it works. Awesome. Well, that's kind of a big win. So let's push up these changes. Oh, those are new files, duh. Git status. Yeah, git restore staged. We'll do the flake lock in a second. We'll get some CIN at some point too. Git push. There we go. And there we go, chat. Working. Perfect. Incredible, actually. Actually, we need to update the README. Because now we don't do this anymore. And we don't have this anymore. Oop. Okay, so one thing I do want to do is I want to kind of maybe. Nope. Way too heavy today. There we go. One thing I do kind of want to do is right now I have this in main, which is like an executable. I kind of want to split it out and do examples. Yeah, I kind of want that to be in examples. And then if that's the case, that would be really nice. And then that way we don't have to deal with any of this. We can kind of just split it out into examples, and then we don't have to actually build an executable. Although it is nice that we can build an executable. Hey, thanks for the follow. I appreciate it. The next one I think we're going to do is so there's another great project, Zin, which is the Zig static site the Zig static site generator. I wrote the docs for deploying this on Cloudflare pages. Basically, this allows you to use the Zig build system to actually build your site. It uses like tree sitter under the hood, and you can do tree sitter syntax highlighting. It's a great project. If you haven't taken a look at it, I would definitely recommend checking it out. But my goal here is to actually get this working in a way where I can use where I can hook into their build system. Which, if we look here, is just you add up this. We add the build, this build step where you actually build your website from the layout, content, and static directory. We add all that together, get it all nice and pretty. And then it, renders your markdown and all of that. And then what we do is we use that inside of our we use that as part of the step, and then you can deploy it right on Spin directly. So that's the next spot. The thing I'm kind of Yeah, and the futures in might make links with the missing final slash to build error. Yeah. So yeah, we'll this is my next spot. And honestly, we might just do that. We can add SYN dependencies. What time is it, by the way? 5:27. All right, chat. I gotta get going. I got a couple things I gotta take care of tonight. Just wanted to kind of walk through, get those things pushed up, have a little bit of a discussion about where we're going from here. I will be back tomorrow for a little bit of a stream. I think tomorrow what we might actually do is we're gonna do Zen right here. That's what we're gonna do. We're gonna add Zen support so we can actually build and deploy the site all in one step. Basically, like we can get a full build of a static site served using my router, and then you're good. So, good stuff, everyone. I hope you have a great rest of your day. Do great things, build something fun, and have fun doing it. Let's find someone to rate. Browse. Software and game dev. Anyone have any recommendations? Throw them in the chat. QR code decoder from scratch. Could be fun. Okay. Yes, let's see. NVIM tree sitter indent? That's what I'm talking about. All right, yeah, let's raid. Let's raid them. All right, everyone. I will see you all tomorrow. Have a good one.